Atom is the smallest part of an element, and of course, an element is that substance which cannot be split into further simpler units by an ordinary chemical process. Each time I teach students about periods and group, I usually give them this trick that I want to introduce to you, how you can simply identify the groups and periods of which an element belong just by looking at the electronic configuration, be it the one of Aufbau Principle or the ordinary electronic configuration. Hello ChemStars, welcome to today's exciting chemistry class with Goodness Ijoma. Please, if you're yet to subscribe to my YouTube channel, go ahead, subscribe, click on the like button icon, click on the notification icon, be part of this family, share with your friends, be free to ask your questions and give your thoughtful suggestion. Alright, let's go back to the lesson of today. So, let's draw this to explain what we mean. The atom is very, very small. Are you getting me? Now, assuming that this is our nucleus, the nucleus present in an atom. So we have our nucleus, and this nucleus is usually surrounded by what we call electrons. And inside this, your nucleus, you know that we have two other subparticles that are present, which is your neutron and your proton, and this is your electron. Okay, this is negatively charged, this is neutral, that means it has no charge, and this is what positively charged. Assuming that you have an element, say lithium, okay, so this is lithium. Lithium has 1s2, 2x1. That means it has a total number of 3 electrons. Okay? Alright. Now, how do you know the group and period to which this lithium belongs to? So here, 1 is the index or 1 is the power. Are you getting me? Now, lithium here has this last energy subshell. The index is 1. And the coefficient, remember coefficient is the number that is attached to something. So I presume, and I'll say that this 2, although is the energy level, so we can say that this 2 is the coefficient. So looking at lithium, I can simply deduce the group and period of which lithium belongs to by looking at this last energy sub level. So for my group, what is the index? 1. So 1. I'll say that lithium is in group 1. The group talks about the index or the power. Okay? So for the period, we talk about the coefficient. So I can say that lithium is in period 2. Remember, this is only for elements that is only filled using the S orbital or S sub levels. So if at all that the element in filling it has to do with the P sub level, let's assume that we want to get the electronic configuration of chlorine, and you know that chlorine is 17, it has 17 electrons. So writing it with the Aufbau principle, we can say 1s2, 2s2, 2p6. Please, the Aufbau principle is displayed right there on the screen. You go ahead and find it in your textbook, or you can download it to study it, okay? You don't cram it. Study them and know how they are placed, and you can use them to write as many elements ever known in chemistry world. So let's continue. We want to find chlorine. So have 1s2, 2s2, 2p6, 3s2. This is 2, 4, 6. Are you with me? 6, that's 10, and this is 12. So chlorine is what? 17. How many is remaining? 5. Okay. So we'll have 3p5. Good. So chlorine has 17 electrons. Now, how do we identify the group and period to which chlorine belongs to? Just by looking at this electron configuration. Here, I told you that the index of power shows you the group, whereas the coefficient, of which I choose to call it, shows you the period. So let's consider the index here. We have P, 5. Are you getting me? If it's only for X, as this one stops with X sub-level, you don't have any problem looking at the other one or the one that was before it. But look at this one. We have P5 here. The previous one is X2. So you don't just go with P, but rather you combine the two, that is the one of X and the one of P. If at all the configuration ends with X alone, just go ahead and pick the index or the power of the S sub-level energy. But if it has to do with sub-energy level of P, do not consider only P. Do well to pick the previous, which is likely to be your X. Are you getting me? So in naming the group of which these elements belongs to, how do I know it? For group, I will now say 5 plus 2, okay? 5 plus 2. This is equals to 7. So for chlorine, it belongs to group 7. The period, how do we consider the period? By the coefficient. Are you with me? Good, by the coefficient. So what's the coefficient of the last one? 3. So it means that chlorine belongs to period 3. Very good. If you do not want to go with Aufbau Principle, there is this electronic configuration where you draw the electronic shell. It can also help you to determine the group and period of the elements. We'll still continue with lithium and chlorine as an example. Let's try it, okay? So we have this shell. Remember, this is your nucleus, okay? Most of you are familiar with this. And for the purpose of this class, I will draw for lithium and chlorine. I will have my lithium, okay? Now, looking at this thing, we will say that the number of shell shows you the number of period, whereas the number of electron as the outermost shell will give you the number of what? Group. Will give you the group to which the element belongs to. What do I mean? How many electron is in the outermost shell of these elements? It's only one electron. This one. These ones are inside. Now, this one is the outermost. What is the valence electron? Okay. So, for lithium, the group is equals to 1. Why is it 1? Because the number of the valence electron is what? 1. And what is the period? The period shows or is gotten from the number of shell, the electronic shell, which is 1, 2. Remember, this one is the nucleus. Are you with me? So the period is what? 2. Beautiful. Now, for chlorine, I will draw for chlorine. We have a nucleus. We have the first shell, which has a maximum of 2 electrons. Beautiful. So we have this. Okay. Make sure your drawing is beautiful. More beautiful than mine. Okay. So we fill up our electrons. So this is 2 and 1. This is 2, 8, 7. Okay. So that it will guide you to understand what we are doing. So I have 8, is remaining 7, right? So let me put my 7 here. 1, 2, 3, 4, 5, 6, 7. Good. So this is my chlorine. Now let's count the electron at the outermost shell, the valence electron. 1, 2, 3, 4, 5, 6, 7. So this shows that group is equals to 7. And the period, how do we get our period? By counting the number of shell. Let's count the number of shell. 1, 2, 3. Beautiful. So the period to which chlorine belongs is what? Period 3. I will leave you with this one to try. Aluminium, magnesium, and calcium. Go ahead, use the Aufbau Principle to represent it and tell us the group and period to which they belong to, and use this electronic configuration to also tell us the group and period to which they belong to. Drop your answers in the comment section and feel free to ask your question. One beautiful thing about solving questions is that they help you to remember more. This leads us to the end of this tutorial. Please, if you're here to subscribe to my channel, go ahead, click on the like button icon, be part of this family. This is Chem Fun, where we make chemistry fun. Feel free to ask your question, give your thoughtful suggestion. I'll see you right there in my next video. I'm Goodness Ijuma. Bye for now.